Hello everybody. In this video we will talk about AM transmitter and receiver. Actually we will divide this into two parts. So today the first part we will be discussing about transmitter section, and tomorrow we will come up with a video on AM receivers. Okay. So here is a AM transmitter. Generally it deals with the wireless transmission of AM signal. Here is a block diagram, which is a very simplified block diagram, I can say. Message is there. This message is also called modulating signal, also called baseband signal. And then this message goes to a block called modulator, which is AM modulator. Different varieties of modulators are there. This modulator gets another signal, another input from carrier. So the output of modulator here, it is modulated signal. Okay, if it is AM system, so here it is AM signal. That modulated signal is power amplified. We increase its power level, and then that is fed to some antenna, and then from the antenna it will radiate, right? Okay, so this is the setup at the transmitter section. Okay, as if you remember, we have said that there is a transmitter block and there is a channel, there is a receiver block. So we are today we are at this point. Okay, so if I need to explain this, then what is happening in AM transmitter is this. In AM transmitter, message is translated to RF by the process of modulation, I can say, which is then amplified by power amplifier and subsequently radiated by the antenna. Okay, as I said that this is a very simplified version. So here one thing is missing, that is impedance matching networks. These impedance matching networks are used between devices. Let's say this and this, in between this antenna system and the power amplifier, in between this. So here we can use this impedance matching network, which is basically a LC network. So what is the job of impedance matching network? It connects one stage with the other. Okay, and why we need this impedance matching network is from the maximum power transfer theorem. What we understand is, if load impedance is equal to source impedance, then maximum power from the source can be sent towards the load. So if maximum power has to be transferred from source to load, then the corresponding impedances must be matched. So here, different blocks are there. Therefore, in order to transfer maximum power from one block to another, we use impedance matching network in between. And what is impedance matching network? Is nothing but some arrangement of inductor and capacitor. Now let us understand the frequency allocation. The AM signal, it covers the frequency from 550 kHz to 1650 kHz with the message bandwidth of 10 kHz. Okay, and if you see this diagram here, so this is the carrier. So how we generate carrier? So carrier has to be generated using crystal oscillators. Okay, so this crystal oscillator, it gives a very stable frequency, right? Fixed amplitude, and this frequency is stable. Okay, so other variation of how to generate carrier wave in a different manner, if I am not using this crystal oscillator, means I have to use LC circuit, tank circuit, parallel combination of LC. So but the problem with LC circuit is it gets drifted. It gets drifted with time, and then other problem is, and it is also not stable. You see, it will be like this, right? Over time, this frequency is not stable and it is decaying also. So that is the disadvantage of this LC oscillator. It is very inexpensive. This crystal oscillator is costly, but it gives very highly stable frequency, right? Other thing is the output of modulator. It is of the order of milliwatt. Okay, so this and this antenna, means the AM wave signal is in kilowatt. You see, so this AM signal transmitter transmits in kilowatt order, and this modulator output is in milliwatt. Therefore we need to use this power amplifier, which will enhance the power of this signal so that kilowatt power can be sent. So that is why we use this power amplifier, and generally we use a class C power amplifier, right? Next is what is the job of AM transmitter? So here it has twofold function. The first is modulation, second is amplification. So in modulation, what it will do, it will, you see, in first is modulation. Here message will be modulating carrier, or carrier is modulated with respect to message. So that process is called modulation. That is the job of transmitter, one of the jobs. Second is that modulated signal, means the output of modulator. That modulated signal is then amplified using power amplifier so that it can be radiated effectively by antenna, right? So these are the two functions of transmitter. Next is what are the types of AM transmitter? So there are two types: low power transmitter, high power transmitter. So how we are categorizing this? So these are categorized based on the modulation. If modulation is done at low power, then corresponding transmitter is a low power transmitter. If modulation is done at high power, then it is a high power transmitter. So these are the two types of two categories of a low power and high power transmitter. I mean two categories of AM transmitters. So now the first transmitter, that is low power transmitter. This transmitter uses a class B power amplifier to amplify the modulated signal. You see here. So this power amplifier will be of class B type. So but there's a problem of using class B type. You see, class B type power amplifier efficiency, theoretical efficiency is 78.5%. So since efficiency is less, therefore it is not used. Okay. So here is a block diagram of a low power transmitter. It contains master oscillator, buffer amplifier, harmonic generator, class C amplifier, and this is also called modulated amplifier. Here message is coming, it is amplified. Message is also called modulating signal. Therefore this amplifier is called modulating amplifier. So the output of this block is a modulated signal. So modulated signal is being amplified using class B power amplifier, and thereby it is radiated by the antenna. On the left side of this section, means of here, this whole section talks about the carrier frequency, FC. Here this section talks about the message. Here modulation is happening, and here amplification is happening, and after this radiation happens. Okay, now what is this MO? MO is master oscillator, as I said, and it is made up of a crystal oscillator, and it suppose I need a carrier frequency FC. This MO will be generating subharmonic frequency, that is called FC dashed. Subharmonic frequency FC dashed means a fraction of FC. Let us say I need 1 megahertz FC. So this MO will generate let's say 250 kilohertz, that is 1/4. So what the argument given is, if the frequency is less, let's say there are two crystal oscillators, one crystal oscillator is giving 1 megahertz, other is giving 250 megahertz, let us say. So this will be more stable because the frequency is less, stability is more. Okay, that is the argument. Now this is a buffer amplifier. Buffer amplifier is generally a tuned amplifier, and it provides very high input impedance, right, to one frequency. That frequency is FC dashed. So this buffer amplifier provides very high input impedance at frequency FC dashed. Okay, in this way this buffer amplifier isolates this with all the succeeding stages. Okay, so my MO is safe from all this blocks. Okay, this is guaranteed by the block called BA, right? Then what is the job of this HG? As I said, this HG is harmonic generator, which will generate harmonics of the input frequency, right? So if FC dashed is a fraction of FC, so the output will be multiples of that. Means output will be multiples of FC dashed, and from that output we will select one particular FC, right? So that is what it is. after low power transmitter, let us see the high power transmitter. This uses Class C amplifier, and this Class C amplifier is having efficiency more than 90%. This Class C amplifier amplifies the carrier. Okay, so here is a block diagram wherein we can see there is a master oscillator, buffer amplifier, harmonic generator, and then there is a Class C amplifier here placed extra, right? So this extra Class C amplifier is called driver amplifier. It drives the carrier, means that the output of a harmonic generator, that power is that FC signal power is less, so that carrier frequency power is enhanced by this extra Class C amplifier, right? And then the highly amplified carrier is fed to this amplifier as an input, and this amplifier is getting another input from the message, right? That message is being amplified, and amplified message is here, amplified carrier is here, and then those high power signals, right, are being modulated, and then it is sent. So what is the difference between high power and low power? Here you see, so here modulation, after modulation power amplification, right, and then it is sent. But here you see all the amplification is done before only, right? So after this modulation there is no power amplification, right? So it is directly sent. So what I can say here is that power level is amplified, power level is increased, I can say, before modulation, and that increase in power level is due to Class C amplifier, which is having high efficiency, right? So that's what. So the last block in the transmitter, the final one, is the antenna. So the antenna is an electrical conductor which comes in different shapes and sizes. The simplest among them is a half wave dipole, right? Half wave dipole means the length of the antenna is half wavelength, lambda by 2, where lambda is the wavelength, lambda by 2 is the length. So the length between the extreme points is lambda by 2. And what is this thing? This thing is just a wire. So two wire taken in this shape, right, behave like an antenna. Okay, so that is the simplest antenna, wire antenna, half wave dipole antenna. So this antenna converts electrical energy into electromagnetic energy and vice versa. So it converts energy from one form to another form. So in that sense it is also called transducer. So let us say this, as I said last day, the communication system. So here there is a transmitter block, we are in this block here. The output is, the transmitter is, here it is the antenna, and here also it is antenna, it is a receiver subsystem. So this antenna is behaving like a transmitting antenna. So whenever my antenna is behaving like a transmitting antenna, it will convert electrical energy into electromagnetic energy. And when my antenna is behaving like a receiving antenna, it will convert electromagnetic energy to electrical energy. That is why, so it is a transducer. So in between these two antenna, the medium is air. In the air, the wave is propagating like electromagnetic wave, right? So here there is a wired system. In the wire, copper wire, like here the wave is voltage wave or current wave. Let's say VI wave. So here also VI wave. That is electrical signal. Here it is electromagnetic energy. So yes, so there is a conversion, right? So this is the job of antenna. So how the antenna functions? So here is, I have written, when current enters antenna, it creates magnetic field around it. So here there is a antenna, let's say dipole antenna. So when current enters here and enters antenna, it will create a magnetic field around it. This magnetic field then creates electric field, right? So this magnetic field is creating electric field, right? This electric field again creates a magnetic field, right? And then this magnetic field again creates electric field, and this process goes on. Okay, so this way we can say electric and magnetic fields are created together. They are called electromagnetic field. This electromagnetic field moves with velocity of light c, and what is c? 3 into 10 to the power of 8 meter per second. And in which direction this electromagnetic field moves? In a direction away from antenna. So if my antenna is here, let's say any antenna, half-wave dipole antenna, okay, so my radiation will be in this direction. Radiation means electromagnetic field, so electromagnetic field will be in this direction. So this is the antenna function. So at the end, if we present a summary, so what we have done, so we know, so we have seen the AM transmitter simplified block diagram, okay, and then we have seen what is the frequency allocation, and then we have seen what is the job of a transmitter, types of transmitter, right? Then low power transmitter, block diagrams, okay, and then we see why we can't use this because of low efficiency. And then we have seen the high power transmitter, which uses a class C amplifier before modulation, right? And then it offers high efficiency, more than 90%. And then we have seen what is the job of a antenna, and then we have seen how it converts electrical to electromagnetic energy, and vice versa. So with this, and then we have also seen what is the simplest antenna, right? That is half-wave dipole antenna. Okay. So with this I close. I hope you understood the concept. Thank you.